Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Nurul Syahira binti Abdul Talib. In this video, me and my team members gonna explain and discuss the topic of depletion types MOSFET, which is called D-MOSFET. There's have two types of D-MOSFET, which is self-bias and voltage divider bias. Depletion type MOSFET bias circuit are similar to JFET, but the only difference is that the depletion type MOSFET can operate with positive value of VGS and with ID values that exceed IDSS. This D-MOSFET can operate in both depletion mode and the enhancement mode. In D-MOSFET have two types, which is P and N channel MOSFET. They also have various parts of P and N channel D-MOSFET, such as drain at the top, gate at the middle, and source at the base. So let's do some calculation exercise about D-MOSFET self-bias. Okay, this is question 1. Figure 1 below shows D-MOSFET self-bias circuit. Determine VGSQ, IDQ, VDS, VT, and VS. Okay, this is the figure from the question. So we find out that IDSS equal to 6 milliampere, VP equal to negative 4 volt. For the supply, 14 volt. From the RD equal to 1.2 k ohm. For the RS equal to 0.43 k ohm. And the RG equal to 1 mega ohm. Okay, VGS must greater than 0 volt. So the first point, I make ID equal to 0 ampere. So from this, I use this formula, which is ID equal to IDSS bracket 1 minus VGS over VP bracket square root 2. So when the ID equal to IDSS is 0, so the VGS we can get from this VP, which is negative 4 volt. For the second point, I make the VGS equal to 0 volt. So when the VGS is 0 volt, so ID equal to IDSS. So we take from this IDSS. Just take in this ID become to 6 milliampere. So the third point, I make VGS equal to VP over 2. So VP is negative 4. Just divide it over 2 and we get negative 2 volt. So the ID, I use IDSS over 4. So 6 milli over 4 equal 1.5 milliampere. The fourth point, VGS must greater than 0 volt. So I use ID equal to IDSS over 2 equal to 6 milli over 2 equal to 3 milliampere. So for the VGS, I just apply KVL from here to here. So from this equation, I get the VGS equal negative ID times RS. So we get ID from here, just take and put negative for in front. So negative 3 milli times 0.43 k ohms. So the equal is I get negative 1.29 volt or 1.3 volt. This is easier to make a plot graph. So from 3 point this, I just take first point 0 negative 4, 0 6 milli, 0 negative 4 and 0 6 milli, and the last point is negative 2 volt and 1.5 milli, negative 2 volt and 1.5 milli. So here, so the 3 point I just make a curved line. So the fourth point is I just want to find the Q point. So 3 milli and 1.3 volt. 3 milli and 1.3 volt. So I just make a straight line, a long straight line. So when the curve and the straight line just intersect, so I drag here point to the ID and VGS. So from that I get IDQ is 2.8 milliampere and VGSQ is equal to 1.2 volt. So we have done find VGSQ and IDQ. So we must find VDS, VD and VS. So VDS, I just use formula VDD minus ID times RS plus RD. So VDD is equal to 14 minus 2.8 milli, which is IDQ for here, times 1.2k plus 0.4k ohm. So I get the answer is 9.436 volt. For the VD, I use formula VDD minus ID times RD. So 14 minus 2.8 milli, which is IDQ2, times 1.2k. So I get the answer is 0.64 volt. So for the VS, when this circuit is operated, so the VS is equal to 0. So VS is 0. So that's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. I'm Azila Majamala Yusof. Today I will explain the calculation for question number 2. Okay, this is the figure given for question number 2. The voltage in is equal to a volt. Assume this first resistor is RD. Second resistor is RS. First resistor D is 2.2 k ohm. Second resistor is RS is equal to 0.39 k ohm. IDSS given is 8 milliampere. VP is equal to negative 8 volt. Okay. First VGS is equal to VP. VP given is negative 8 volt. Okay. First VGS is negative 8 volt. And the ID is equal to 0 also. Second VGS is equal to VP over 2, which is VP is negative 8 and over 2 is equal to negative 4 volt. ID for second VGS is IDS over 4. IDS as given is 8, so over 4 is equal to milliampere. For VGS 0, the IDS also 0. Okay, from the calculation above, we can get this graph. Okay, from this graph, we get the IDQ, which is 2, and the VGSQ is minus 4 volt. This IDQ and VGSQ is get from this minus 4 is because VP over 2 here, and the IDQ is because IDSS over 4, which is 2 milliampere. So from this graph, we can find the VDS. VDS is equal VDD minus ID times 2RS plus RD. The VDD is 18 volt minus 2 milliampere times to 0.39 k ohm plus 2.2 k ohm. So the VDD is 18 volt minus 5.18 volt is equal to 12.82 volt. For VD is VDD minus IDRD. Okay, VDD is 18 volt minus 2 ID 2 milliampere times to 2.2 k ohm is equal to 18 volt minus 4.4 volt is equal to 13.6 volt. For VS is VD minus VDS. VD is from this calculation 13.6 volt minus to 12.82 volt from this VDS. So VS is equal to 0.78 volt. That's all from me. Thank you.
My name is Muhammad Sharifuddin bin Asmadi and I'm from BEI 2/1. Okay, today I want to show the calculation about the voltage divided by a circuit for the MOSFET. Okay, this is the circuit that we get from question 5. Okay, first of all, I need to find the plot for Q point, which means VGS is larger than 0 volt. Okay, for the first point, I use VGS is equal to 0, so ID is equal to IDSS, which means it is 6 milliampere. For the second plot, for the second point, I use VGS is equal to negative 3 for the VP and ID is equal to 0. For point number 3, I use the formula VP over divided by 2 and I get negative 1.5 volt. For IDSS, I use IDSS is divided by 4, so I get 1.5 milliampere. IDSS is equal to 6 milliampere. Okay, for point number 4, I use VGS 1 volt and ID is equal to IDSS times by 1 minus VGS divided by VP power of 2. So I get 6 milliampere times by 1 minus 3 volt divided by 3 volt. Oh, and power of 2. So I get 6 milliampere times by 1.33 power of 2 and I get the ID is 10.6134 milliampere. And then I need to find the VG for the plot for the right side. I use the formula R2 divided by R1 plus R2 times VDD is equal to 10 mega divided by 110 mega plus 10 mega times by 18 volt. It is equal to 1.5 volt. Then for the plot at the right side, I use VGS equal to VG minus IDRS. ID is equal to 0 and VGS equal to VG. So VGS is equal to 0 and ID is equal to VG divided by RS, which means 1.5 divided by 150 and I got 10 milliampere. Okay, for the plot, this is plot that I drew, starting at negative 3 volt and then 1.5 volt then at the third point 0 volt, and then 1 volt. There's -3, -1.5, 0 and 1 volt. And for the right is 1.5 volt and 0. VGS 0, 1.5 is for the left and left side. For IDQ and VGSQ, I found it when it intersect between these two lines. At this I mean is this line. Which means I get the IDQ is 7.5 milliampere and VGSQ is 0.4 volt. Okay, thank you.
Assalamualaikum. My name is Muhammad Nazmi bin Muhammad Nabil. Now I will continue for question 3, which is Syarifudin part. So VDS is equal to VDD minus ID times by RS plus RD. So for this question, VDD is equals to 18 volt. ID from the graph is 7.5 milliamp and RS is 150 ohm plus RD, which is 1.8 kilo ohm. So 18 volt minus by 14.625 is equal to 3.375. This is value for VDS. Now I will explain for value for VD, VG and VS. Okay, for VD is equals to VDD minus ID times by RD. VDD, like we know before this, VDD is equals to 18 volt minus by ID, which is 7.5 milliamp, times by RD, which is 1.8 kilo. So the value for VD is 4.5 volt. Next for VG, the formula for VG is R2 times by VDD divided by R1 plus R2. So for R2, which is here, is 10 milliohm times by 18 volt, which is VDD here, and divided by R1 110 milliohm mega ohm plus by 10 mega ohm for R2. So the value for VG is 1.5 volt. To find VS, the formula is VD minus VDS. So value for VD is 4.5 volt, which is here, and for VDS is 3.375, which is from here. So the value for VS is 1.125 volt. So that's all from me and my group. Thank you.